What's going on, guys? Welcome back to the channel. Today we're going to be going through integration again, but this time via the substitution method. A bit easier than integration by parts, but we're going to be going through the lion's share of it today. And if you haven't already, make sure to like, subscribe, make sure to share these videos with your friends if they could find value in it, and of course, make sure to turn that notification bell on as well, guys. So without further ado, let's get right into it. Alright, guys, so for the first bit, we're just going to be looking at the process here. So what is the integration by substitution process? What does that look like? And to understand the process, we're going to start off by saying, well, number one, we need to find u, because after all, what this is u substitution, and we need to find u, and ideally we want to find u ideally such that du over dv is part of the integral. Now you might be a bit confused. I mean, what is this about? Well, put it this way: if we've got x squared, and we've got 2x dx, and we've got an integral here. If we let u, equal x squared, therefore du by dx is equal to 2x. So therefore du is equal to 2x dx. So as you can see, that slots in there. So we just got u du as the integral, right? That's just an example here. So that's what I mean by this. It just makes everything a lot easier. And we're next gonna just sub in u. We're gonna sub that in, right? And 3, we're gonna evaluate. We're gonna evaluate in terms of u. And number 4, we're going to rewrite the answer in terms of x, or whatever the initial variable was, right? So find u such that du by dv is part of the integral. Then we're going to sub in u. We're going to then evaluate in terms of u, and then rewrite in terms of the original variable. Most of the time is x. Alright, guys, so here we've got a classic example. And that is the integral of 6x times 3x squared plus 4 to the power 4. So in this scenario, what we need to do first is find a value of u. So I'm going to say this: well, let u equal 3x squared plus 4. We've done that. So therefore du is going to equal 6x dx. Why? Because du by dx is equal to 6x. Then we just times the dx over. We've got that. Now all we have to do is plug this in. And if we plug this in, right, what do we get? We get u, alright, u to the power 4 du. And we can integrate this now, and we can say u to the power 5 over 5 plus c. Make that 5 a little bit stronger. And now we've got it in the answer in terms of u. We just have to get the answer now in terms of x. So how do we do that? Well, we're just going to plug in for x. We're going to say that we can therefore say, okay, fine, that's going to equal 3x squared plus 4 to the power 5 plus c. Okay, and that's going to be the final answer to the question there. Now, it's very rare you'll get a question as easy as the one we just did. Most of the time, if it's an integration by substitution question, it's going to require a little bit more thinking. Okay, and in this scenario, we've got exactly that. So you've got the integral of z square root z squared minus 5 dz. So in this scenario, what I'm going to do firstly is I'm just going to rewrite it. So I'm going to say the integral z squared minus 5 to the power half dz. Okay. Therefore, what do we get? If we say let u equal z squared minus 5, I can therefore say that du is equal to 2z. Okay, so du by dz is equal to 2z, which means that du is equal to 2z dz. Okay, brilliant. So with this now, with this we can push this further, and we've got our u here, but we've over here we've got z dz. So what do we do? Well, what we need to do here is we need to make an alteration. Okay, and we're going to say half du is going to equal z dz. Okay, so we've made an alteration here. We've done that. So we can say now, cool. We plug this in. So we can say, well, that's going to give us the integral of got u the power half. Okay, so it's half du. Brilliant. Brilliant. And that's going to give us what? Give us a half of u to the half du. If we integrate this, we can get a half, okay, u to the 1.5 over 1.5 plus c. Let's do in 1.5 because it's just easier to write. And once you do that, we can then say, okay, we're going to take out we can take out the 1 over 1.5, so we'll have a half times 2 over 3 u 1.5 plus c. Okay, so we're going to have a third of u 3 over 2 plus c, which means that, remember what u was? U was z squared minus 5. So therefore we're going to get a third of z squared minus 5, okay, to the power of 3 over 2 plus c. Okay, and that's going to be the final answer to that question. Now we have this question. Okay, we've got the integral of sine t over cos to the power 3t. So how does one go about approaching questions like this? Well, a good way to approach questions like this is to say, well, we've got here sine t over cos to the power 3t. Now, we know that the derivative of cos t, okay, is going to equal minus sine t, right? And that gives us a little hint here, because that means that we've got a u and we've got a du by dv we can find. So I'm going to say, let u equal cos t. Therefore, du by dt is equal to negative sine t, which means that du is equal to negative sine t dt. Okay. Brilliant. Now we can sub this in. So if we sub this in, what do we get? We're going to get, we're going to have minus du over u to the power 3. Okay? Which is the same as saying what? Minus u to the minus 3 du. Okay? Perfect. Now with that, we're going to get, this is going to equal now minus a half of u to the minus 2 plus c. Okay, because remember, plus 1 divide by the exponent. And now we just need to sub the original back in. If we sub in the original, what we get is minus a half. Okay. Cos t to the minus 2 plus c, which is going to give me 1 over 2 cos squared t plus c. Okay. And that's the final answer to that question. Just to summarize here, we set u equal to cos t because du by dt is equal to minus sine t, which allows us to plug things in much quicker. Okay. And with that, okay, we therefore sub then the u and du. That should actually be, that's fine actually. Got that there. Okay, we just expanded it out a little bit, changed it up, and we subbed in the original to get this. Wasn't too difficult. Right, now for this one, guys, we've got the integral of x over the root of x minus 1 dx. So what do we do here? Because if we let u equal x minus 1, then du is equal to dx. And technically speaking, that's problem solved. Right? But this here is unaccounted for then. So we're left in a bit of a pickle. So what can we do instead? Well, we can say, okay, we can say that if u is equal to x minus 1, right, then we can say x is equal to u plus 1. That's the first thing we can do. Okay? Because we're going to get the integral here of u plus 1. This is just another way of doing it, but still substitution. Okay? And we're going to have the square root of u at the bottom. But what's du going to be? Well, dx is going to equal du here. So we're going to have du here as well. And there you go. We've made that a integral of u. The next phase is to look into this a bit more. So we can say we've got the integral of the we can convert this, right? We can say that's the same thing, saying the integral of square root of u plus 1 over root u. Okay. Du. And we can therefore say that it's the same thing as saying the integral of half u to the half, sorry, plus u to the minus a half du. Right? Once we've got that, we can say the following. We can say that, know what our u is. Okay? So this will be important. So we're going to plug that in eventually. Sorry, our x. But what we're going to do first is we're going to say, well, if we integrate this, we're going to get 2 over 3, sorry, u to the power 3 over 2, plus 2 u to the half, okay, plus c. Now we just have to plug in the x variable. So we're going to get 2 over 3 x minus 1 power 3 over 2 plus 2 x minus 1 to the power half plus c. And we can simplify this further. Okay, if we simplify this further, we'll get x minus 1 to half. Get 2 over 3 x minus 1, okay, plus 2 plus c, which translates into what? X minus 1 to the half plus 4 over 3 c, which gives me 2 over 3 x minus 1 to a half x plus 2 plus c. Brilliant. And that's going to be the final answer for that question, guys. Just to recap again, in this scenario we let x equal u plus 1. Okay, so if we plug that in, we got to this, and that then allowed us to simplify the equation out, where we could just do our classic integration method and then plug the x back in to get to this. Alright guys, so now we've got a scenario where we've got a definite integral. Okay, we've got a definite integral here. So similar concept, okay, similar concept, but at the same time a little bit different. So what I'm going to say right, is I'm going to say let u, in this instance, equal 1 plus 2x to the 3. Okay. Therefore, du is equal to 6x squared dx. Okay. Brilliant. We've got that. So we can therefore say, right, that we've got our u here, but our du doesn't really fit. So what can I say? Well, we need x squared dx. So I can say a sixth of du is equal to x squared dx. Alright? Brilliant. But remember now, we've also got our limits of integration. So what do we do for them? Well, when x equals 0, because this is x equals 0, u 1 plus 2, 0, which equals 1. When x equals 1, u is equal to 1 plus 2, okay, which gives me 3. Therefore, I can say that the integral between 1, 0 of x squared 1 plus 2x3 to the 5 dx is the same thing as saying 1 over 6, okay, between 1 and 3, u5 du. Okay. You can see here. Now we just evaluate it. So if we evaluate this, we get a sixth, okay, of 3 over 1. u5 du equaling a sixth of u6 over 6. Okay, that's all going to be between 3 and 1. And we can therefore say, well, that's going to give us, if we take out the 6 again, we get 1 over 36. Okay. Plug the 3 in, we get 3 over 6 minus 1 over 6. Sorry, 1 to the 6, which gives us a final answer of 102, 9. Okay, and that's going to be your final answer. So just to summarize, guys, so let u equal 1 plus 2x to the power 3. We worked with that to see that 1 over 6 du must equal x squared dx. Okay. We then said, okay, we've got bounds here, so how does it work with that? Well, with those bounds, we just said when x equals 0, u is equal to 1 plus 2 times 0, which equals 1. And when x equals 1, u is going to equal 3. Okay. Plug everything back in, integrate as you normally would, and we get this. So in this scenario, we don't have to go back to our x values. We can stick with the u. So at the end of the day, it's the value. It's the value at the end that matters. Alright guys, now what if we've got an exponential function? What do we do then? So we've got the integral here of 3x squared times e to the 2x to the power 3. Now what do we do? So what we're going to do here is we want to, again, simplify this as much as possible. So I'm going to say let u, okay, equal 2x to the 3. Okay, and I say let du is equal to 6x squared dx. Okay. Now, in this scenario, we've got a situation where we want to get e to the u, okay, by itself. And we've got 3x squared dx here. So how do I get to 3x squared dx here? Well, I'll divide by 2. So say a half du is equal to 3x squared dx. Alright. Brilliant. Now if I do that, I can say that the integral of 3x squared e to the 2x power 3 dx is going to give me a half of the integral e to the u, okay, du. And we simplify this so much now, okay? It's all about trying to find the easiest thing to be u and making sure that you get a corresponding du by dx, which will correspond to the derivative of u. Okay, very important. So the derivative that's going to be next to the value of u. Okay, that's what we need to find. So if we integrate this as normal, what do we get? Well, we get half. Okay, we get half EU, because remember, it's just integrals just itself. Half e to the u plus c. And if we plug this back in, we're going to get half e to the 2x 3 plus c. Okay, and that, guys, is going to be your final answer. Okay, so just to summarize there, we found u to be 2x power 3. We found du by dx, okay, that was equal to a multiple of 3x squared dx, and we were able to use that then to just find what half du is, okay, which is 3x dx. Plug both in, we get this. Integrate, we get this, and then plug back in, we get this. And that's the final answer.